Well, good evening, everyone. You'll notice that the video quality on this video is not very good, and that's because my phone is out of power, so I have to use my webcam to record this one. So I brought the phone on a charger here. As you can see, it's charging. A little light. I don't know if that's going to show in the not terribly great video, but it does seem to be working. Of course, what I'm really interested in is this Dollarstore charger, right? Dollarstore contactless charger, which I spent a couple of bucks for. It has warmed up quite a bit charging the iPhone here for a few minutes. I thought having the oscilloscope, which would be better in scope mode for this purpose, would be a fun thing to try out with this little thing. And I actually bought it a while ago intending to take it apart. And then, I don't know, it was in my bag and went out to the office, so it was getting used there. So let's have a look inside this and see what there is to see. Hopefully there'll be something fun to connect the oscilloscope to, and we can get some idea of a couple of things. A couple of things that I'm interested in would be, what frequency does it operate at? What frequency does it operate at when it's charging? And how does that change when it's in? At the moment, it's unplugged, but if it were plugged in and idle, what's it doing now? So let's have a look inside it. I think there are just a couple of screws holding this together. And let's see what we can see. I think these little feet come off. And I don't think there's going to be a lot of sort of analog electronics of the sort that I'm usually interested in here. I assume this is just going to be a chip, some passives. And that's about it. Let's get a larger screwdriver. And we'll try this one. Yeah, that's better. I can't remember what I paid for it. A couple of dollars Canadian. Can't imagine more than that. Maybe $3. Okay, so we got the 4 screws out. We'll have, presumably this bottom piece comes out. Yeah, looks like it. Okay, well, the whole thing comes out quite easily. So we've got a little plastic ring which shows an LED. There's another screw here with a little metal support holding it in place. So well, that screw went somewhere. All right, so let's slide this down maybe the cable a bit. Let's see if we can lift it out. And that's it. So we have a couple of pieces of plastic. We've got that. We've got a USB cable. So we've got a coil here. So we can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coils of what looks like Litz wire coming on to, which would make sense because the frequencies this probably operates at. We've got a single chip with a number on that. I don't see a number. This is going to absolutely blow out this picture. No, though there is something on it. No, I don't think so. I can't read it. We've got I mean, it looks like we've got 3 transistors here. There's a capacitor. That'd be a resistor, maybe. That might be a resistor. That looks like a capacitor. I've got no idea what that is. It has a number on it, but I can't see it. This one is 1803. Not sure. Anyway, I can't really read the other ones right now. But that's not really, I mean, I suppose I do care about what it does, but I mean, at some level I don't really. I want to see what this is doing. And I note that we can very conveniently hook onto here. So let's do that. Let's hook the ground onto there. Let's line that up. Plug it in. We'll hit auto. Okay, there we go. It's pulsing. Let's turn on, let's see if I remember how to do this. Menu. So we're just hooked up to the back. We'll turn on menu, we'll scroll through until we have measure. We'll turn on frequency. And that's 5 volts. Okay. Yeah, I think that's fine. Sorry, I knocked the camera again. All right, so we can now see we've got 171 kilohertz. All right, so let me just make sure that the power bank, so let's see what happens when we put a phone on it. So it's dropped. And we can see how much the, of course I will get notifications in this context, but we can see how much the frequency has dropped. We've gone down to 120 odd kilohertz. Actually, it hasn't dropped that much. It's wandering around the same frequency. And I really can't say anything about the shape of the frequency there. Let's see what happens when we pull the phone away. So as the coupling gets more distant, it starts to look more like, and now we get the pulsing at 171 kilohertz. If we move it closer, and as the coupling is better, do you think it hunts for an optimum frequency within a certain range? Let's see if I move it around, the frequency changes. I don't know quite exactly where the antenna is in an iPhone SE, so I presume in the middle. So it looks like the frequency actually gets lower when it gets close to it. The other thing we could do, which I don't have here, just a moment. Let me find my USB tester here. Okay, so here we are back. Let's just move this over to here. So we can see the voltage and 0.05 amps. Right? It won't be much higher than that because this power bank likes to shut off completely. And so 0.06 amps. So let's move this close to it. So the voltage is dropped. So this is going to be drawing more current, and it's drawing just about an amp, which, if I remember correctly, is what it's rated for. So what happens when we move this around? So we can see we're looking at just under 120 kilohertz, and let's turn this around so it's upright. Okay, hopefully that works. So we're going to, 115 to 120 kilohertz. So let's, and we're drawing just under an amp. So let's move it over a little bit. So we're up to 172 kilohertz. And we're down to 0.5, so it's now disconnected. Right? It doesn't think it's charging. We can see the power light came on there. So, and we're still at 111 kilohertz. If we go down here, the voltage has gone up, and the frequency has gone up, but it's getting no current. So, what we can see, and now we've got good coupling, we've got 1 amp, and we've got 111 kilohertz there, 115 kilohertz, so the same sort of range that we were dealing with before. And now, drop the phone away, and it starts toggling on and off, but at about 170 kilohertz. So it looks like its standby signal is about 170 kilohertz, and then its power frequency is, right around 115 kilohertz. So, given that we can see some funny spikes and things, and this is funny shaped, I bet this produces quite a lot of harmonics. I haven't used this particular one near a radio. We could try that. Oh, what happened? The ground came off. Just a moment. We could try this particular one near a radio. I think that would be pretty interesting, but I do have a proper name brand one that I use by my bedside radio. And that one, you really can't use AM radio around it at all. So let me get an AM radio, and let's try it and see what happens. Again, my assumption is going to be that there are all sorts of harmonics around this stuff, but I don't know if I can demonstrate that on the oscilloscope. Let's think about it. So let's find a radio. I don't know if you can hear that in the background. I have a little Panasonic set to a sports station here for us to listen to. This is now shut off because the power bank's powered down. Let's see if I could line stuff up a little bit better. Okay, we'll put the power bank in between the, so we've got oscilloscope, noise source, power bank, and the radio. And the radio, as I said, set at the sports station. This is now off because the power bank's powered down. So let's turn the power bank on. So I don't know if you can hear that. Here, let me bring the microphone over to the radio.
Elizabeth II's favorite sport. Now I think about Britain and all of its,
So, as you can hear, as this turns on and off, it creates a click in the radio, which is set at 5:90 a.m. Okay, so let's see what happens when we bring a phone into it.
Okay, I was kind of close because I guessed that you were going to ask me what her favorite team was.
That actually improves it a little bit. But of course, so, of course, depending on how we orient the antenna on the radio, we have slightly different effects. So, I think we can safely say that if you're planning on using an AM radio, you might want to unplug your wireless chargers, although I don't think that should surprise anyway. I haven't noticed a problem on FM. It doesn't really surprise me when you consider that this, 170 kilohertz is, certainly just off the low end of the AM band, right? So this is 520 at the bottom end of the AM band, 160, where it used to be before they extended the AM band in North America. Sorry, I'll bring this up here so that you can see better. So it's just times 10, right? So that's 520 kilohertz AM. And if we read over here, it's 170. So, we're down here, or something like that, with this signal from here. We're not that far off. And these relatively inexpensive devices, as I said, are almost certainly producing harmonics down there, but I don't know how I could see that without something like a spectrum analyzer, which is not a tool I own. Maybe there's a way of doing it with the oscilloscope, but that's probably beyond me. Anyway, I hope this has been an interesting look inside one of these little contactless chargers, right? Which uses coupling. And I think it's a good example of how you can find out a fair bit with a simple oscilloscope while playing with these sorts of things. Sorry, I did have this cable all over there though. That's a fun little device. Hopefully I'd probably take it back to the office. It's kind of convenient to have there. It saves me getting out a cable. But clearly, if you're interested in medium wave radio, these things need to be unplugged when you're trying to do it. Any sort of medium wave DXing absolutely has to be unplugged. And as I mentioned before, here in Toronto, our signals are quite strong on the AM band. Not quite as crazy as they are on the FM band. With one of these sitting next to a fairly decent AM radio, yeah, it's just a loss. So maybe across the room might be okay with local stations, but I wouldn't count on it. So when you're going around unplugging your power supplies before doing medium wave DXing, you might want to also look at these. And I wouldn't be surprised if there are harmonics into the shortwave bands as well, into the high frequency. I mean, the only saving grace to it is that I don't think it'll go very far, but added to the other noise from power supplies, I'm sure this thing is producing noise too, which on this cheap cable is probably some of the chirping we were hearing might be some of that too. This could certainly end up on the cable, and then it's going to go farther. So yeah, and the dollar store one, I mean, does it have it? It claims FCC compliance, but do you believe it? I'm not sure I do. Anyhow, hope you enjoyed this little look inside a wireless phone charger, and hopefully we will be back to higher quality video recording for the next one. Thanks a lot.